only have this homework tonight. And most of you are like at least halfway, if not all done with it. So that, again.
Are we going to have time at the end after this?
Dan probably is.
No.
I'm still working. No,
Well, I don't know.
Like the last 7.
Well, let's go fast. I was on 39. These ones are hard.
Oh.
If Dan's saying it's hard.
You're not 21 yet.
It's just confidence.
Okay. So this lesson is actually the one lesson I really, really need you to do well in. It's really what you do for calculus in the next coming up chapter. You need to know slope, obviously. Slope formula. Slope is equal to your rise over run, which you've all heard of before. It's equal to your delta y over delta x, which means your change in y over your change in x. But you should be more familiar with the formula y2 minus y1 over x2 minus x1. Okay, so that is your slope formula. And then in addition to that, know the slope-intercept form, which, Bennett, I believe you just said. Y equals mx plus b, where the m is your slope, and this is your y-intercept. Okay, so slope comes in several ways for us. All right, now slope there are 4 different types of slope, okay? And I originally graphed this, but I'm gonna kind of do this in a different way. Your slope can be negative, which graphically, what does that look like? What does the line look like it's going? Down. So you read a graph from left to right. So your graph will look like the slope is going this way. That would be a negative slope. In the equation, in your y equals mx plus b equation, then you would have y equals, negative mx plus b. The slope has to be negative. Okay, so you look for that. And obviously, you could have positive slope, which would be going up. Your slope would be positive in your equation. But these are the 2 that kind of always seem to confuse students, and I want to make sure you know how to do it. The difference between 0 and undefined, or I'm going to put no slope for a reason. So do you remember Miss Davis did this whole thing called Hoy-Vernox? Yeah. Okay, so I want to just explain what Hoy-Vernox is. Okay, correct. If you are horizontal, you have a 0 slope, your graph is y equals. So meaning you would have, for 0, you would have a horizontal line. This would be a 0 slope. Your graph, the equation would just be y equals, and then wherever you're intercepting right there. Whatever that y-intercept happens to be, we'll call it b, okay? So if this was intercepting at 2, y equals 2. If this was intercepting at 7, y equals 7. There's 0 slope, 0. The Vernox comes from vertical lines are no slope, but we call it undefined, same thing. It's always written as x equals. Okay, that's where this little phrase comes in. And again, x equals wherever the x is intercepting at. I don't know, I'll say A, point A there. Okay, so please know that. Please understand this. You have to really understand this for what we're going to do when we talk about tangent lines and all those fun things. But on the homework, again, that's you're going to do tomorrow, but I'm just teaching the lesson now. You'll have easy questions just like find the slope of 3, 4, and 3, 1. Something easy like that. So what would that be? What would be your slope? y2 minus y1 over x2 minus x1.
3, 0.
4 minus 1 over 3 minus 3. A lot of students ask me, do I have to go this way to this way? No, you just have to stay consistent. If you go right to left, then you always go right to left. If you go left to right, then you always go left to right, okay? So if I go, 1 minus 4, then I have to do 3 minus 3 this way. But even so, 3 over 0, what is 3 over 0? Is that no slope, undefined? Why is it undefined? Can't divide by 0. So please know that this is not a 0 slope. I still have students in calculus telling me this is 0 slope. That's incorrect. It's undefined. Okay? Let me give you another one here that might, oh yes, this you'll definitely have a question on this. Use the point -3, -1, and a slope of 0 to find 3 other points. Use the point -3, -1. This is such an easy question, and for whatever reason, students are like, I don't understand, I don't know how to do this. So just kind of bear with me. I'm going to draw this because this is now how you have to think. You have to think like you're drawing. So go to the point -3, -1. Draw that dot. A slope of 0 means what type of line is it? Horizontal. Hoevernocks. Okay. Find me 3 other points now that are on that line. Give me any 3 other points right now.
-1 and 50, 0. What? It's -1, 50, 0. Oh. 50, -1.
1 negative
1 -1. 50 -1. Yes. 0 0. No.
0 negative
0 -1. Okay. Notice again, your horizontal line, the y would always remain the same. So something very easy there. Okay. All right. Now, the last and final thing for this whole entire section right here is to talk about the point slope form. The most important. Oh my gosh, I cannot stress this enough.
How do you know that line is vertical again? I mean horizontal.
It has a slope of 0. Hoy. H-O-Y. Y equals is horizontal. If it was,
Vertical.
if it said slope is undefined, then you'd got to go this way and find 3 points that are this way. Good question. All right. We didn't do this a lot last year. I feel like you were my first group. No, you might have been my second group that didn't get to go through this as much. You did it on the pre-calculus review at the beginning. And I'm kind of nervous because this really is an important formula for calculus. Can you write this one down? Y minus y1 equals m times x minus x1. Have you seen this before?
Yes.
Okay, good. This is the point slope form. Because if you have a point and you have a slope, you can write an equation of a line. So on tonight's homework, they're going to use this phrase, write an equation of a line, write an equation that's parallel, write an equation that's perpendicular, write an equation. Anytime they say write an equation, this becomes your best friend right here. Okay. The slope is obviously there. You just need to find a slope of that line. They might give it to you. They might not. The point that you're going to use is here and here. So this first y and this first x never change. You always write it as y and as an x. So I'm going to give you an example, very basic, and then we'll work through some, parallel and perpendicular ones. But it'll say, write an equation with a slope of 3 through the point 1, -2, okay? So just using this equation. So here's what I sometimes do. I kind of give myself a little box here, like I say, okay, I need a slope, I need a point. I need a slope and a point. That's what I need to write an equation. Any equation, you need a slope and a point. The slope they gave me, 3. The x they gave me was what? 1. The y? You plug these numbers in here into that point slope form. The first y remains y. But the second y is the one you're plugging in. So y minus -2, which is y plus 2, okay? equals 3, which is m. X remains x, but that becomes minus 1. I want you to write it always in slope-intercept form. So once you get to here, I want you to solve for y, always, because that's usually in our brain how we can figure out what it looks like. So y plus 2 equals 3x minus 3, y equals 3x minus 5, is that right? Yes. Okay. So there's your equation that has a slope of 3, and it actually goes through this point 1, negative 2. Easy, right? I say that every year. I think every year everybody's going to know how to do it, and they don't. Okay, but then they're going to ask you to write parallel and perpendicular equations. Do you remember what makes two lines parallel? We just talked about this. Same slope. What makes two lines perpendicular?
Opposite reciprocal.
Good. Write this down if you don't remember it. Opposite reciprocal slopes. Okay, and now we're going to practice that, and that lesson will be over. This was a quicker lesson. Probably should have started with this one first.
Yeah.
Nah, I think you would have tuned me out come the second one. All right, so I want you to find an equation of a line passing through the point 2, 1. I take that back to negative 1. It's a negative 1. Sorry. And is parallel and perpendicular. These are those symbols for parallel and perpendicular to the line 2x minus 3y equals 5. There is a lot going on, and I'll explain it in a minute once you write this all down. Find an equation of a line passing through 2, negative 1 is parallel and perpendicular to 2x minus 3y equals 5. We're going to find two different ones. Yeah. Yeah, you're like, how can that be? One's parallel, then we're going to find another one that's perpendicular. Okay. All right. So again, things I need. Slope, point. They gave me a point, yes? What's your slope? What do you have to do? Solve for y. Can I teach you a trick, though, when they give you this way? Because I don't think you know this or remember it from Algebra 2. Maybe you do. To find slope when it's written in ax plus by equals c form, maybe some of you will remember it, maybe not. You could do this formula. M equals negative a over b. Have you ever seen that one before? Maybe? No? No? Oh, maybe yes. Okay, good. So like, what's your a? Your a is 2, right? So negative 2 over, what's your b? Negative 3. Yeah, this is the ax plus by form equals c. And so there you go. Your slope is 2/3. Had you solved this for y, you would have also gotten 2/3. All right, solve it for y. You'll see. I'll do it real quick. Negative 3y equals negative 2x plus 5 divided by negative 3. Oh, look at that. Negative 2 over negative 3. It's the same thing. So. All right, so now I have my slope, and here's my point. But the problem is I need to find a parallel, and I'm going to find a perpendicular. I'm going to start with parallel because it's the easiest one. So I want to use a parallel slope to 2/3. What's the parallel slope to 2/3? 2/3. I want to use my x that they told me to go through, which is 2. I want to use the y, negative 1. I'm going to take these, and I'm going to plug it into the y minus y1 equals m times x minus x1. I'm going to take those three right there and plug it in. So use my point slope form. Y minus or plus 1 equals m times x minus 2. Y plus 1 equals 2/3 x minus 4/3. Oh, let's see if we can do this. Y equals 2/3 x, what? Minus 7/3. Very good. That is the parallel equation to this line that goes through that point. Okay. Now the perpendicular one. What's the only thing I have to change right here? So what would it be?
-3/2.
-3/2. Your x is 2, your y is still -1 because you're still going through that same thing. Listen, this doesn't just change. Can I just write -3/2 here? No, Your b is going to be different. Okay? So it'd be y plus 1 again, -3/2, x minus 2. Whoops. And what does that make? +3? So -1 is +2. This is the perpendicular equation to that line through the point 2, -1. Crazy, but true. All right. And last but not least, this is a question. It will be on a quiz and it will be on homework. Given the point 3, 8, I'm just trying to give you everything. Write a parallel and perpendicular equation to the line x equals 4. So my last one, it's actually here is an example where you cannot use the point slope form. Do you know why? It does. This has a slope. What's the slope? Not 0. Undefined. How do you put undefined in an equation? You don't. So for this reason, we're going to graph it. We're going to do this graphically, and it's going to make more sense. So if you were to draw this right here, graph the point 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, right there. Would you all agree? Okay. And I want you to, according to this, given the point, write a parallel and perpendicular equation to the line x equals 4. Okay, well, where is the line x equals 4 located at? What kind of line, first of all, is it? Horizontal or vertical? Vertical at x equals 4. So right here, would you all agree? So if I said, okay, whoops, write a just parallel through that point, wouldn't you draw this? How do you write that equation?
X equals 3.
Done. Here's the parallel line. X equals 3. If I said, okay, through that point, make it perpendicular. Y equals 8. Done. And you do not have to do then this section homework until tomorrow. You've got to do the rest of it. All right, you're welcome. Thank you for